by the end of this chapter, we're hopefully going to be able to graph a lot of different types of functions very quickly if they're in their vertex form. The first thing we're going to start off with is talking about how to easily graph quadratics. So hopefully we all remember quadratics, and there's a certain form that makes them super easy to graph in. Then we will also be discussing absolute value graphs, do some square roots. We'll figure out how to graph those quickly, and I think we're going to also do cubic functions. Not a very good drawing of one there, but and if we have time, maybe we'll talk about how to do circles, even though circles are not a function, but the idea kind of works for those as well. All right, so let's go ahead and get started. So we're going to be talking about quadratics today. So quadratics, they have a certain pattern that they grow by. In this graph here, where it starts at 0, 0, where the vertex is at 0, 0, that's what we call our parent graph. This is like the simplest quadratic function that we could graph. So from our vertex, hopefully you guys see that, let's get a different color here. When we go over 1 from our vertex, we go up 1. And then when we go over 2 from our vertex, we end up going up 4. I don't know if you guys can see that on here. And then when we go over 3, we go up 9 to get to our next point. And then since we know we have a line of symmetry through our vertex, we can flip all those points over and graph it very quickly. But again, this is how we would graph the parent graph. So, but I guess we can do it like this. We're going to be changing values to slide this graph around, just like that. All right, so it gets a little sloppier here. So what is a vertex form? So this is the vertex form of a quadratic. So if we look at this, you can see we have an A value, an H value, and a K value. So your A value, we got right here, get a different color, is our stretch factor. And we're only going to look at those. We will look into them a little bit deeper, but we're going to focus on when A is 1 and when A is -1 and what that does. So the H value inside this is what moves your vertex left or right, and the inside lies. So notice there's a negative there, so it's always the opposite. So if it was x plus 5, that means we would go to the left 5 because the inside lies. The K value is what moves the vertex up and down. So, and it tells the truth, it's on the outside. And then we have our rules written here for our vertex. So if A is greater than 0, that means we go up with our points. That means it opens up. And if A is less than 0, that means it opens down. So that's kind of a good way to kind of check our work. And that means if it opens up, we would have a minimum value. And if it opens down, we would have a maximum value. And it would be at that K value, the Y value of the vertex. So we are also going to be talking about domain and range, but we'll just jump into that when we actually get into the example. So here's our first example. We've got x squared minus 4. So remember, we have to think about what this is. So if we, I'm going to put the general form here, or our vertex form. A times x minus h squared plus k. So we have to be able to identify what that value is. So looking at that, that is our k value, because notice it's not inside the parentheses with the x. So that is what our k value looks like. The a value in this situation is 1 because it's 1x squared. And the h value is 0 because it doesn't exist. It's not there. It's like x minus 0 squared. So let's go ahead and graph this. And that means we need to go down 4 units. The k value tells us to go down. Whoops. The scrolling is not working too well. 4 units. So I'm going to go down to -4. And the h is 0, so we don't go left or right at all. So now I'm going to use that pattern that we just talked about. I'm going to go up 1, over 1. And I'm going to flip that point over. Then I'm going to go over 2, up 4, 1, 2, 3, 4. And I'm going to flip that point over. I'm 2 units away, so I go 2 units this way. And won't be able to connect the dots, but I'm going to go over 3, and then I go up 9, so it would be right here. So now I'm going to, there we go, I can fit them all in there. So now I'm going to connect the dots best I can. All right, so should have a little more curve to it, but that's the best I could do. So now let's identify our vertex. There's our vertex. It is at the ordered pair 0, -4. That's our vertex, h comma k. Now let's go ahead and, well, do we have a max or min? We have a min value because it's opening up. It has a low point, and that min value is -4. So we're able to identify those. So now we need to talk about the domain. So our domain here, if we keep thinking about this graph, the domain is all the x values that are graphed. This graph is going to go to the left forever, and it's going to go to the right forever. So every quadratic we graph will always have a domain of all real numbers because it'll get wider and wider forever. So now the range is a little different. Notice we do have a low point. So our range is all the y values that are graphed. Well, what is our lowest y value here? It is the k value, the -4. So since this thing's opening up, we're going to say y has to be greater than or equal to -4 because that is the lowest y value over here. You can see it. That's -4. And it goes up forever. So now the x-intercepts, this is what we were practicing before, the solving. We could solve them graphically, we could factor it if we could possibly factor, we could use square root property, we could use quadratic formula. Well, this one, the x-intercepts are pretty easy because we put dots on the x-axis. So there's our first x-intercept, and there's our second. So we don't even have to solve anything here. So our x-intercepts would be at what? -2, 0, and at 2, 0. All right. Now, y-intercept, we can look and see here. We've got what? -4 there. That's where it crosses the y-axis. So this would be at 0, -4. Now, if we wanted to find the x-intercept algebraically, we could have just plugged in 0 for y and solved for x. And then if we wanted to find the y-intercept, we could have plugged in 0 for x and solved for y. All right, so here's another example. Notice again, I'm not going to write everything down here, but this is the k value. It's a -5. So my a is a 1 because that's what's in front here. My h value is 0 because it's not there, and my k value is -5. And we can plot -5. And remember that pattern. Since the a value is 1, we're going up. We go over 1, up 1. And we can flip that point over. Then we go over 2, up 4. And hopefully some of you are seeing why this pattern exists, because what we're doing is we're going over 1, and then we're going up 1 squared, because that's what a quadratic does. It squares things. And then when we go over 2, we go up 1, 2, 3, 4, because 2 squared is 4. So we square the vertical movements. So then we go over 3, 3 squared is 9. So we can go up 9. And if we went over, 4, yeah, we'd go up 16 because we would square it. That's what a quadratic does. So now we connect our dots. All right, and we're just going to leave the x-intercepts and y-intercepts alone for right now. Let's just focus on domain, range, vertex. But we can keep practicing. But I think, let's focus on one topic at a time. Where's our vertex at? That's right, 0, -5. Do we have a max or min? It opens up, so we have a min value. Exactly right. And it is at -5 too, same k value. So our domain is all real numbers. And our range, since it opens up, it's going to be y is greater than or equal to some number. Well, that number is always the k value, -5. Not bad, right? All right, so let's take a look at this guy. And again, we're going to, just for the sake of time, I don't want to make this video too long. I realize it's going to drag on if I talk about everything in this video. This one is a little different, but still only moving through something up and down. But notice that negative out in front. So that means our a value is -1 here. Our h is still 0, and our k value is -1. So this changes our graph a little bit because the negative a value means we go down. So our k is at -1, our h is at 0, so that means we don't go left or right at all, and we go down one, put a dot. Now since the a value is negative, we go down instead of up for all of our movements. So we go over 1, down 1. Then we go over 2, down 2 squared, which is 4. And we put a dot, we can flip that one over, and notice we're running off the graph. So all we can do now is connect our dots. So hopefully you're looking at this one going, oh, well, this one doesn't have any real x-intercepts, and you're exactly right. It does have one y-intercept at -1 though. So our domain is always the same. It goes left forever and goes right forever, so it's all real numbers. So now the range changes because when it opens down, we have that high point. Oh, I forgot to point out a vertex, so I'll do that in a minute. So since it's opening down, we have to say y is less than or equal to the k value. All right, I skipped over vertex and max or min. So our vertex is located at 0, -1. And since we are opening down, we have a max value, and that is at that -1 value. All right, so let's look at this problem. Hopefully right away you're seeing some things are a little different here. That are numbers inside parentheses. So let's go through and label our values. So right here it looks like, what would our a value be? It would be a 1. And then our k value would be a 0. So a is 1. Our h value is going to be 3, remember, because the inside lies. And our k value is 0. So this means our vertex is actually getting moved 3 units to the right. So it's going to go right there. So we can write our vertex out at 3, 0. So now, since the a value is 1 and it's positive, we go over 1 up 1, flip it over 2 up, 2 squared, which is 4. We can flip it over. Then we're going to run off the graph, so all we can do is connect our dots. Hopefully you did a better job than I did. All right, so your domain, exactly right, all real numbers, because that's what it is every single time. So now your range, we have a low point there, right? So I guess we should talk about the max or min. So since we have, this is a min value, and it is at 0, because that is the y value of the vertex. So your range, since opening up, is y is greater than or equal to the k value, which is 0. So that's using the h value. All right, so now let's mix them up both together here. So now we have to move left and right, left or right, and up or down. So our vertex here, so the opposite of this number is h, so that'd be a 3. And then the k value is the y value, so it'd be a -3. And our a value is 1, so we know this thing's opening up. So I'm going to go right 3 and down 3 and put a dot. I'm going to use my rules. Over 1 up 1, over 2 up 4, that's right. And remember, we're just squaring our horizontal movements to get our vertical movements. Then we need to go over 3 up 9. Then we can connect our dots. So we already have our vertex. So we also have a min value here, right? Because this is opening up, and it's at -3. So our domain, you got it, all real numbers. It opens left forever and right forever. Now our range, so since this is opening up, its y is greater than or equal to that lowest y value of -3. Okay, so here's one other one here that we'll do. So notice this one is moving left and right too, and it's got a -a value. So this one's opening down. So we're going to go a equals -1. So our vertex will be what? -2, 5, right? Because the inside lies for our h value. So we go back 2 up 5, put a dot. And now since we got a -1, we can go over 1, down 1. Remember, it opens down. Over 2 down, 1, 1, 2, 3, 4, right? 2 squared. Then we go over 3 down 9. Should be right here. Flip that one over right there, right? Try to connect the dots the best I can. All right, not too bad. So again, our domain, all real numbers. Our range, since it's opening down, is y is less than or equal to the k value, which is 5. And we would have a max value at 5 because it's a high point. All right, so in review, hopefully we remember that we have our growth pattern, remember here, that's over 1 up 1, over 2 up 4 from the vertex, and we can flip those points over 3 up 9, because we're squaring our horizontal movements to get our vertical movements. So remember the h value is on the inside of parentheses and it lies. So if it said like x minus 2 squared, why isn't it like, there we go, we would slide it over there. That would be x minus 2. If we wanted x plus 3 squared, we'd have it right there. So let's say if we had, now the number on the outside is up and down. If it was x squared plus 2, we'd be up there, x squared minus 3 down here. So let's say we had something like this, y equals x minus 2 squared minus 3. That just means what we go right to because the inside lies, and we go down 3, and that's where our graph would be. So that's the big ideas from today. Have a good day.